We've written some equations of quadratic functions in the past when you had one point in the vertex. Today, we're going to use your systems of equation solving skills to do it when you don't necessarily have the vertex. So if you just have 3 points that your parabola passes through, go ahead and write a system of 3 equations, plugging in each point's x and y values into your standard form for a parabola to get 3 different equations. So if I plug 1 in for my y value and then replace x with -2 in my standard form, I'm going to get an equation that looks like that. And then if I do my last point, if I replace y with 2 and my x is with -1, I'm going to have my third equation. Now I am going to go ahead and simplify. So multiplying by all those zeros is just going to give me 5 equals c. Then if you go ahead and, since you have c, plug it into your other 2 equations, it'll make your life easier. Continuing simplifying, I'll have 1 equals, if I square my -2 and take it times a, 4a minus 2b plus 5. And then simplifying my green one there, similarly, I'm going to have those 2 new equations. If I do a little bit of elimination and multiply that second new equation I got by -4, then I can add it to my first new equation and end up with my a's eliminating. So I'm going to go ahead and add those 2 equations together, and you get -7 equals 2b minus 15. And then I'll go ahead and add 15 to both sides to get 8, and divide by 2 gives me b equals 4. Now that I have b, I can go ahead and pick any of my equations that had just a and b in them. So I'm going to go back to that first one that I had, the 1 equals 4a minus 2b plus 5, and replace b with my value that I just got, and then solve for a. I could go back to any 3 of the original equations that I wrote and plug in b there as well. So if I plug b in, I'm going to end up with 4a minus 3 equals 1, so a equals 1. So you have all 3 values. Don't forget to actually write the equation for this parabola. So replacing your values of a, b, and c in standard form is going to give you y equals x squared plus 4x plus 5. So this one's pretty similar, except you've got your data in a table of values instead of a set of points, but I can turn these into a set of points with my input months on my market and my output, my number of units sold. And then if we're modeling this using a quadratic, we can go ahead and, like we did before, use those 3 points as our input and output values to get a system of 3 equations. So I am doing that, kind of sped this up so you don't have to wait forever for me to write. But we're going to have to do a little bit messier system of equation solving this time, because I'm not going to immediately get my value of c when I substitute in any of these points, because none of my coordinates were 0. So I've got this system of 3 equations in purple right there that I am going to solve. Let me just go ahead and take my first 2 equations, and I see that I can eliminate my value of a if I multiply my first equation by -4 on both sides and get a new equation. It's going to have -16a, that if I add it to that second one, I'll get 0a. So if I go ahead and do that, I'm going to get an equation that only has b and c in it. Now, since I eliminated a there, I need to pick 2 of those original purple equations and eliminate a again. So this time I'm going to take the top and bottom one, and make sure you stick with that same variable. Eliminating a requires me to multiply the top one by -25 on both sides, and then I can use that new equation that I got, add it together, and end up with another equation that only has b and c. So just be super careful when you're doing all this, because it's so easy to make a mistake. Now that I've done that, I'm down to a system of 2 equations. So those 2 new ones I've got underlined in green. I'm going to multiply one of them by -10, because then I'll be able to eliminate b if I add them together. And I'll finally get to an equation that only has a single variable and be able to find C equals 300. Now I'm going to go backwards a little bit, so either one of those two red equations that only has B and C in them, I could plug C into. I'm just going to use that one right there, the negative 940, plug in my value for C, and I'll get a value of B as 10. And then now that I have B and C back to any of those three original equations, I'm going to go with the top one and plug B and C in there. I won't show it all because I'm out of space, but you end up with A equals 1/2. And then don't forget to write your equation. Whew, we got there. Yay! Okay, there's a second part that asks after how many months will the number of units sold be double what it was after 2 months? So that would make my output 644 units if my after 2 months amount was doubled. So let's take my function that I just wrote, and I'm trying to find the amount of time that it takes to get 644 units created. So substituting in 644 for my output, I'm going to solve for t. It's a quadratic, so I'm going to get 0 on one side, and then I am just going to go for quadratic formula here. Doesn't look like that would factor, or at least I don't want to try. So if I plug everything into the quadratic formula, I am actually going to end up rounding a little bit here, get approximately the number of months, because that radical does not break down nicely. So I'm just going to approximate it. And if I do the subtraction, I get a negative number of months, which I couldn't have. So the one that actually makes sense is just the 18.07 months.